recording. Okay, so we are finishing off 4.4's lesson. All right. The first one's not that bad. It's in factored form for us. Remember how this works. You learned this in grade 11. If you have an equation where 0 is on the other side, and you've got it in factored form, just think of this as two numbers. A number times a different number makes 0. So you have to explore those two possibilities, right? If you times two numbers together and get 0, one of them has to be 0, if not both of them. So either 2 sine x plus 1 makes 0, or 2 sine x minus root 3 makes 0. And I'm going to solve for both these cases. So this one, the sine of x would equal negative 1/2 when I solve it. And for this one, the sine of x would equal root 3 over 2 for the second one. My pen's kind of too fat. Let me get a better looking pen here. Oops, come on. There we go. That's better. Okay, so now, what kind of answers do they want? They want radians. Okay? Should I expect to need my calculator for this one? No, because I know when the sine of x is negative 1/2, and I know when the sine of x is root 3 over 2. So I'm going to find those two places. When is the sine of x 1/2? When is the y value 1/2? What family are we in? The y value is 1/2 at pi by 6 and 5 pi by 6, right? Because that's the two places where the y value would be 1/2. Okay, oh, but I'm sorry, it's negative 1/2. Oh, geez, I'm not even looking at my own answer. So that'd be down here. Okay, let me undo those things. Undo, 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 undo. Okay, so we want to be, one more. We want to be down here. So this is the pi by 6 family, but okay, we want positive answers. We want to go from 0 to 2 pi, so we want this number and this number. And this one is 11 pi by 6, and this one is 7 pi by 6. Okay, so that's my two answers for this one. Okay, when is the sine of x positive root 3 over 2? That happens when I'm in the pi by 3 family, right? Because then that would be comma root 3 over 2. I guess I didn't write the actual point here, negative 1/2. There we go. And the other place where sine is positive would be the mirror of it over here, which is 2 pi by 3. So that's my two answers for that one. X is pi by 3 and 2 pi by 3. And that's it. There's my 4 answers for that question. Okay. Feel free to stop me if you have any questions. All right, now the algebra gets harder. All right, what do we do with this? For this one, think of how you would just solve x squared minus 5x minus 6 equals 0. And if the first thing that comes to your mind is I'd use the quadratic formula, I'd say, why don't you try factoring first? Why not use the most efficient tool in your toolbox? If you couldn't factor it, then yeah, quadratic formula will work. Okay, so you would factor this to be x minus 6, x plus 1. That's what I'm going to do here. So I'm going to have tangent of x minus 6, that's a 6, times tangent of x plus 1 equals 0. All right. So that would be the tangent of x equals 6, and the tangent of x equals negative 1. Well, one of those I could do without my calculator. I know when tangents are 1 and -1. They happen at the 45-degree family. Ooh, how do I know I'm in degrees? Because it's telling me, it's telling me to look over a domain of degrees. And it only wants answers from 180 degrees to 360 degrees. So that's answers down here, right, in quadrants 3 and 4. Now, tangent can't be -1 in this quadrant, so the only answer that works is this answer here, which is, this is the 45-degree family, so this would be that answer there. 360 minus 45, that's the 315-degree place. So that's that answer. How do I find this answer? Do I know when the tangent is 6? No. This one I need a calculator for. Okay? So first things first, I find my reference angle. So reference angle is the inverse tan of 6. And we'll do the same thing we did last time. Okay, now we want to be in degrees. My calculator is already in degrees. Don't always check to make sure you're in the right thing. Inverse tan of 6. And that would be a reference angle of 80.5377 if I go to 4 decimal places. Degrees. All right, where is that? Let's make a reference angle for where I can put that. Okay, it's got to be positive, but it also has to be between 180 and 360, so I don't care about the top 2 places. The top 2 places don't have any answers. The top 2 quadrants, I should say, don't have any answers. So tangent's positive in this quadrant, and it's this quadrant with a reference angle of 80.5 blah, blah, blah degrees. So how do I figure out the actual real name of that angle? I would add 180 to it. So my x is going to equal 180 added to that, which is 260.5377 degrees, and then underline them, circle them, put boxes around them. Sometimes people even just go, therefore, x can be 260.5377 degrees, comma, 315 degrees. Like they'll put all the answers in one line just to make it easier for me to find. Okay? Any questions on how I did that one? Notice this one only came up with 2 answers. How come? Last one had 4 answers. Why has this one only got 2? Yeah, it's because the domain's more restrictive. We're only looking for answers in a sort of a narrow band from there to there, right? The top 2 quadrants didn't count, so there's no answers to be had. Okay? All right. How about I give you a minute and let you try this one? Guys who might be watching this on video, you could fast forward a little till you see me writing again. How did I get the 315 is a question that I just saw in the chat. 315, because I know tangent is 1, right? Hang on, I'm writing with the highlighter. Hang on, I don't want to do that. I know that the tangent of 45 degrees is 1, right? So I know that I have to be in the 45 family. So, but I can't be here because tangent's positive. Tangent's negative here, but that's not in the domain they want. Can't be here, so it has to be this one. So I knew this was 45 degrees that way. Laura, does that help? Let me know if that made sense to you, my little explanation of where I got the 315 from. Okay, got it, good. All right. Letting you try that one. And yes, you have to factor. No, you can't go to the quadratic formula. Well, you mean you could. If you're absolutely stuck, have fun. I think your formula sheet will always have the quadratic formula on it. But you shouldn't need it. Mm-hmm. No, what do you think's happening? Okay. Someone in the class has already realized that this one actually is kind of trolling you. What's happening here is that when you let's see, what two numbers times to make negative 12 and add to make positive 1? I think it's going to be plus 4 and minus 3. Is that what you had? And then you get the sine of x is equal to negative 4, and the sine of x is equal to 3. And at this point, right, remember that sine of any angle has to be between 1 and negative 1. Remember that the very definition of sine, back in grade 10 when you first learned SOHCAHTOA, was that it's the opposite divided by the hypotenuse. Hypotenuse has to be the largest side, right? Sine of an angle still has to be, at the end of the day, a number between 1 and negative 1. It can't be bigger than 1 or smaller than negative 1. So that doesn't have any solutions to that equation. But the next one, which is actually the same algebra, does. Because look what happens on the next one. Cosecant x plus 4, cosecant x minus 3, and so that means that the cosecant of x is negative 4, the cosecant of x is equal to 3, and then to solve those, do the reciprocal of both sides of the equation. Aha! Those have answers, because they're between 1 and negative 1. Now, are they numbers that I know? No. This is a calculator question. So for this one, you get to use your calculator. And you're going to get 4 numbers, and we want 4 decimal places. So I'll give you a minute to try that yourself, see if you can find the 4 answers. Now, what kind of numbers do we want? What do you want your calculator to be in? Notice how this tells you what you're looking for. We have to be in radians here, right? Okay, let's see if I can catch up to you. I'll do the one on the left first. And remember that for that one, I'm going to find a reference angle. I'm not going to tax my calculator by putting in negative angles for it to figure out, because I don't want, I'm not going to tax my calculator by putting in negative ratios, because I don't want negative angles for an answer. So I'm going to take the inverse sine. Oh, wait a minute, I got to be in radians. There we go. I'm going to take the inverse sine of 1/4, and that gives me a reference angle of 0.25, I guess that'd be 27 if I rounded it to 4 places. Don't slap a degree sign on that. I'm not in degrees, right? I'm in radians. And now, where should that answer be? So here's where I got to do my little sketch. How many times will I hit 0.25 radians for sine between 0 and 2 pi? Well, sine is only positive on the top 2 quadrants. And let's see, 0.2 is pretty skinny, right? All the way across. 180 degrees is 3 radians roughly, 3.14. So 0.2, this is going to be about there, and it's going to be like there. Now, how do I figure out this one? Well, for that one, I'm going to say, well, first of all, x can be 0.2527. That's, remember, you are your own reference angle in quadrant 1. But when I'm in quadrant 2, I'm going to take pi minus that. So this number here is pi minus 0.2527. And I already have that number on the screen, so I don't need to erase it.
Isn't sine negative?
No, sine. Oh, crap! I did the same mistake I did again. Thank you for saying that. Okay, let me get out of here. No. Sorry, give me a mulligan on that, would you guys? It's the one on the right where sine's positive. Sine is negative here, so let's start that over. So my reference angle, according to the cast rule here, has to go down. So it's 0.25 that way and 0.25 that way. So it's going to be pi plus, and so this one's going to be pi plus 0.25, blah, blah, blah. And this one is going to be 2 pi minus the 0.25, blah, blah, blah. So once again, I might store this 0.25 number so that I don't have to repunch it. If you have a calculator where you're not sure how to do that, just let me know and I can help you. Okay, so the first one is pi plus. So pi plus the last answer I had. So that's going to be, so this is not one of the answers. This is. I get 3.39. I just said 9 and I wrote a 4. 3.394. I guess 3 is my last digit if I round to the fourth place. And then this answer I would get by going 2 pi minus. So 2 times pi minus, I'll go recall A because I stored it in memory A, 6.0305, I guess. And there's the first two answers. This one now. My sine, inverse sine of, I forgot to put the negative 1 on that. Inverse sine of a third. So the inverse sine of 1 divided by 3 is 0.3398 when I round it. Now this time, sine's positive, so I'm in the top two quadrants. So again, you are your own reference angle there, but now I want this one, and that one I'd calculate by going pi minus the 0.3398. So next answer here is 0.3398, and my last answer I'm going to get by taking pi minus that. So pi minus my answer, 2.8018. And there we have it. And there we go. That's about as tough as these get. Maybe you might get one with a little uglier factoring that you have to deal with. And they give you a little note there. What if you hit one that isn't factorable? Then you try the quadratic formula. Or if it's factorable but you're stuck and you just can't see the factors, don't waste too much time. Go to the quadratic formula. Okay? It will be on your formula sheet. Now, there's only one more complication that this stuff has. What if we don't give you a domain that we want the answers in? We want you to express all of the possible answers. So, usually they'll say that. We call this the general solution. And generally what that means is the domain is all real numbers, and they'll say that by saying XER or theta is an element of reals, or they want a general solution. So, for example, here's one that's just kind of the old type question. Solve for cotangent is equal to 1 over root 3 over the interval from 0 to 2 pi. So we've done lots of these now. First of all, I'll change that to tangent, which means that it's root 3. And I should know where tangent is root 3. Tangent is root 3 at pi by 3 degrees. And according to the cast rule, tangent's positive down here. So that would be 1, 2, 3. This is 4 pi by 3. So theta would be pi by 3 and 4 pi by 3. But what if, instead of it saying this, it said this? So think about that picture that I just did. it would mean that not only would I hit an answer when I got to here, and hit another answer when I got to here, I would hit this every time I spun around. So I would hit this number when I go there, etc., etc. Every time you spin around, you'd hit that number. So how do you say that? So what I do is I start with answers for one revolution, which is basically the A answer, right? Then add infinite more revolutions. And here's how you say that. You would say that theta is equal to, and this is kind of a set of answers, so you could use set notation to make yourself look fancy, pi by 3 plus 2 pi k, and 4 pi by 3 plus 2 pi k. But you have to define what k is. K is an element of, I'm going to use I for integers, but some people probably already know this. The fancier, more technical letter that they use for the set of integer numbers is the letter Z. And I don't remember what the word was. I think it's a German word. Somebody might know it, but you could write or Z. And the Z, I'm going to write this better. The Z's usually a fancy looking Z too. It has an extra line there. Just like real numbers, technically the symbol, here in our booklet we're just using a capital R for real numbers, but in textbooks you'll notice that it's capital R with an extra line like that for real numbers. I'm not too terribly worried about being that formal. Now, remember what this says, right? This says, I'll translate this to English. In English, this says the value of k is an integer, which makes sense, right? Think about it. When k is 1, it's pi by 3 plus a spin of 2 pi. When k is 2, I've spun 4 pi, or spun around twice. And notice k can be negative, because you could hit these answers by going backwards as well, right? I'd hit that one, and then I'd spin around and I'd hit that one. So that's basically what it means. Okay, let's do another one. Solve over 0 to 2 pi, and then for all real numbers. Okay, this one I'd need a calculator for, right? So my reference angle here would be the inverse tangent of 4, right? So my reference angle is, okay, I'm in radians this time, so let's say, is my calculator in radians? Yes. So the inverse tangent of 4 is 1.3258 if I round to 4 places. Okay, so now, where is tangent negative? Tangent is negative in quadrants 2 and 4, right? C, A, S, T. So 2 and 4. So I have a 1.3 reference angle here and a 1.3 reference angle there. That should be a straighter line than that. And I would like to know this answer here. So that would be pi minus that. Okay, so once again, so I don't lose the accuracy on those decimals, I'm going to store this in my memory. And then I'm going to go pi minus that answer. So the first answer is 1.8158. And you don't put a degree symbol on it. Remember, that's radians. And then the other answer, this answer here, I'd get if I went 2 pi minus 1.3258. So So 2 pi minus the answer that I stored earlier. 4.957, and then the thing, it's a 3, but the thing after the 3 is a 6, so I got to say a 4. There we go. Now, if the domain is all real numbers, I would say that theta equals, and again, I'll use set notation here, my first answer plus spin around as many times as you like, and my second answer and spin around as many times as you like. I guess I don't really need a comma here. And then k is an element of integers. All right. Your turn to try one. This one, you don't need a calculator for. So I'll give you a minute to try it. All right, let me try catching up to you here. Oops. Oh. Okay. What mistake did I just make because I wasn't paying attention to what I'm doing? I'm supposed to be working in degrees. Thank you. There. So there's the answer if my answers are between 0 to 360, right? I'd hit a 0 for cosine here, and I'd hit a 0 for cosine here. But what if I want the general solution? Where is all the places to infinity that cosine of an angle is 0? Well, I could say that beta is equal to 90 degrees plus, now it's every time I spin, right? So I can say 360 degrees times, now historically you can use any letter you want as this variable that just determines how many times you spin around, but for some reason almost every textbook uses k when you're doing radians and n when you're doing degrees. I have no idea why. So I'm going to say 360 times n, and the other one is 270 degrees plus 360 degrees times n, where n, again, is an element of integers. Now, I could have actually made that a simpler answer. This is fine. This is a perfectly good answer. I'd give it full marks. But if you're into efficiency to your answers, could anybody have made this smaller?
90 plus 180.
Oh, there you go. Because these two answers here are exactly 180 degrees apart, you could say that you would hit everything that you're hitting here if you said that B was 90 degrees plus 180 degrees times any number. You get that? Notice these two things are the same thing. You just have to vary how many n's, how many times you're spinning. I'm perfectly happy with either of them as an answer, by the way. Now, can you always take the two answers and simplify them to one? No. Notice on the last one especially, right? These two guys, well, these two guys here, actually on this one you kind of could, because these guys, this was a straight line. These ones were 180 apart. But go back to the previous one, and you would not be able to, because this is not a 180 degree or a pi difference. So you wouldn't be able to do that. But on ones where you know that you have either 180 degrees between the two solutions, or pi if you're in radians, feel free to make a simpler answer. The textbook might do that for you. So if you're doing textbook questions, you might actually see that that's what they did. Okay, that's all I needed to do for the lesson, so I'm going to shut my video down. And I've already updated the blog on this assignment. Okay, so let me shut the video down. Thanks for watching, anybody who's watching.